Yes, ma'am.
A very happy morning to everyone. And as today is the first day of Navratri Pujan, may Mata Rani bless our respected sir and all the future officers present here for today's amazing session of geography by our esteemed, hardworking, and dedicated Sandeep Mahajan sir. As we all know, a teacher can change the perspective of his students. What else we can think about Mr. Sandeep Mahajan sir, as he is our teacher today? What else can be a better beginning of our day? More than this, let's make the day productive and positive. Now I want to share something regarding geography. What is geography? Its literal meaning is the description of Earth, but ideologically, it explains the past, illuminates the present, and prepares us for the future. And we all are here to seek for a better future. For it, just be hopeful and cheerful, and then this journey of UPSC would be so amazing for you all. Now, without any further ado, handing today's lecture to our sir. Thank you so much. Over to you, sir.
Thank you. Good morning, all. So in yesterday's class, we were discussing about conduction, convection, and radiation. In conduction, we read that when Earth is hot, air layers closer to Earth will be hotter. If Earth is cold, air layers closer to Earth will be cooler. So, conduction occurs closer to the Earth's surface. Second, we spoke about convection. In convection, we argued that with increase in height, if temperature decreases, I repeat, with increase in height, if temperature decreases, normally what are we going to observe? There will be vertical movement of air. Else, there will be no vertical movement of air. Third, we spoke about radiation. Incoming solar radiation is called as, incoming solar radiation is short wave radiation. Outgoing terrestrial radiation is long wave radiation. So, on the basis of this, we saw that different gases absorb differently. In that, we observed that carbon dioxide does not absorb short wave, but it absorbs long wave, right? Similarly, water vapor absorbs both short wave and also long wave, whereas clouds reflect almost short wave, almost long wave. Now, given this particular understanding, let us see some more applications associated with this. The first basic thing is about carbon dioxide. So guys, everyone, can I say carbon dioxide property is doesn't absorb short wave radiation, but it absorbs long wave radiation. Now I'll apply this concept. Everyone understand this carefully. Now I have carbon dioxide. I have carbon dioxide. In one region, I have ice. In another region, I have Earth's surface. Now, let me tell that sun's rays came, Earth got heated. When Earth got heated, Earth started releasing long wave radiation. Yes, you tell me, will carbon dioxide absorb long wave radiation? Yes. Now, can you people tell me this one? Short wave came. It hit the ice. After hitting the ice, what will happen is, will ice absorb or will ice reflect? Will ice absorb or will ice reflect? Guys, ice will send back. When it sends back, guys, when it sends back, can you people tell me, will it be short wave or long wave? Incoming is short wave. When it sends back, it is short wave. Very good. Guys, reflection means if short wave comes, short wave goes. Fine. If long wave comes, long wave goes. What is reflection? Reflection basically means whatever comes will be sent back. So if short wave comes, we send short wave back. If long wave comes, we send long wave back. Now you tell me, carbon dioxide, does it absorb short wave or it doesn't absorb? Carbon dioxide doesn't absorb. Now you tell me, if carbon dioxide does not absorb, is it good for climate change or bad for climate change? Can I say, okay, I'll ask the other way around. Good and bad, confusion will be there. Yeah, I'll ask the other way around. Will it heat the earth or not? It does not heat the earth. Why it does not heat the earth? Because carbon dioxide doesn't absorb. Correct? Carbon dioxide will not absorb. Now, can you people help me out in this basic concept? Right? Now, I am a person who is an IAS officer of a metropolitan city like Delhi. Right? You people are IAS officers of Delhi. Now, government called you and told, in Delhi, temperature is increasing. Right? Temperature is increasing because of greenhouse effect. I want to reduce. Can you tell me what should be done? So one thing they will ask you, what should we do to the buildings? Should we paint it light in color or should we paint in dark color? What will reduce heat? What should we do? Which color, light color or dark color? Light color. Guys, okay, one side I have dark color. Another side I will have like, light color or white. Let me say I put white. I have carbon dioxide here also. I have carbon dioxide here also. Can you tell me what will happen if there is dark color? Will there be long wave radiation or short wave radiation? Long wave radiation. Long wave radiation is absorbed. Now you tell, if I have light color, what is going to happen? Will it reflect? If it reflects, carbon dioxide doesn't absorb. Yes, guys, this is urban management. This is urban management. In smart cities and all, they do this. Today, it is mandatory that on top of the building, white color paint must be there. Okay. Second, roads. Do you need to have a tar road, black in color, cement road, white in color? Which is better? White cement road is better. In Bangalore, guys, they went for what we call as white topping of the road. White topping of the road. They converted all dark roads into white road for a while because they want to reflect it. Do you all understand the concept now? Reflection. Yes. Now, let me use the term here. I have white color, yellow color, black color. Guys, when sun's rays comes, white sends back. Let me assume what came is 100%, 10% is absorbed, 90% is sent back. Yellow, what comes is 100%, 30% is absorbed, 70 is sent back. What comes is 100%, 2 to 3% will be sent back. So in every process, some percentage will be absorbed and some percentage will be sent back. And whatever is sent back is called as albedo. What is albedo? Reflected part of the sun's rays is called as albedo. Clear, guys? Here, what is the albedo? This is albedo. 70% is albedo. Here, 2 to 3% is albedo. So, what is albedo? Reflected part of the solar radiation is called as albedo. Now, can you people tell me? Tundra region covered with, like, ice. Tundra region. Desert. Grassland. Forest. Guys, which one will have more albedo, guys? That means where it will be reflected more, tundra. Good. Okay. Among the three guys, among the three, desert, grassland, and forest. Tundra means cold desert, polar region. Can you tell me among the three guys, these three, desert, grassland, forest, which one will have more albedo? See guys, for those people who are telling forest, in forest if trees are there, will trees absorb solar radiation or will they send it back? Does trees require solar radiation, guys? Why do trees require solar radiation? Photosynthesis. So as photosynthesis is there, normally forest doesn't send back, but forest tries to absorb. Can you tell me here? Grassland also absorbs. Desert, at least some is sent back. At least some portions are sent back. So guys, highest albedo is tundra region. Tundra region means polar region. Second is desert. Third is grassland. Fourth is forest. Okay. So can I say, as trees increases, albedo decreases? Is that correct? As trees increases, albedo decreases. Do you understand this concept now? Albedo. What is albedo? Reflected part of the sun's rays is called as albedo. Can you write below, guys? Reflection. Reflection. Yeah. Shubham, carbon dioxide absorbs long wave. Carbon dioxide doesn't absorb short wave. And in reflection, what goes out is short wave. That is why carbon dioxide is not absorbing. This is the property we use to reduce greenhouse effect. Yeah, can you please write? Reflection. Reflection. When when the waves are when the waves are sent back, when the waves are sent back in the same wavelength, in the same wavelength, then it is reflection. Then it is reflection. Full stop. Reflected part of sun's radiation, reflected part of sun's radiation is called as albedo. Is called as albedo. Full stop. Light colors have more albedo, compared to dark colors. Next, tundra region is covered with snow, and it reflects more insolation, Next point, as the green cover increases, albedo decreases. Because plants absorb solar insolation for photosynthesis. So forest will have less albedo compared to grassland. And grassland has less albedo compared to desert. Okay. Ma'am, you're asking why dark color gives longer wave. You see, sun's rays came. What is going to happen if dark color is there? It absorbs. Earth absorbs. And if it absorbs, Earth will become hot. Now, every hot object would radiate heat to the surrounding. Correct? So Earth will also radiate heat to the surrounding. And when Earth is radiating heat to the surrounding, it will be in the form of long wave. So if there is a dark color here, absorbs, it becomes hot and then radiates. But if there is a light color, let us say there is a light color, so as soon as the sun's rays will come, it will be sent back. So here absorption reduces. Ma'am, I didn't understand. What is the reflected part of? Okay. So water tanks and rooftops are generally white in color, so it doesn't absorb heat and water become cool. Good. So yes, guys. What is the use of forest absorbing? Forest absorbs, that itself means photosynthesis will happen. Carbon dioxide gets converted into oxygen. Sir, when do short wave radiation comes and when long wave? Good ma'am. Yeah, this I wanted to tell you, everyone. One, we will try to talk about the difference between radiation and reflection. First basic thing is, hotter the object, shorter the wavelength. Cooler the object, longer the wavelength. This I have told yesterday. Again, when will you have short wave? When will you have long wave? Short wave is when the object is hotter. Long wave is when the object is much cooler, comparatively cooler. Now let me take a case of radiation and let me take a case of reflection. This is a very, very important concept. This, whatever you have doubts, you ask me, because questions will come. Fine. See guys, incoming is short wave radiation. Earth becomes hot and outgoing is long wave radiation. So here, incoming is short wave radiation. Earth does not become hot. Earth doesn't become hot. And short wave is sent back. So if coming is short wave, going is long wave, we call it as radiation. If coming is short wave, going is short wave, we call it as reflection. Clear guys? Just make a note of this. Just make a note of this. Yeah. Ma'am, if coming is short wave, going is long wave, we call it radiation. If coming is short wave, going is also short wave, we call it as reflection. Draw this guys in your notes. Yes, simultaneously both can have. Yeah, ma'am, if at all water vapor is there, short wave has issue, because water vapor absorbs short wave. Okay, guys, dark color doesn't produce, white color doesn't produce. Dark color absorb. Okay, dark color absorb, becomes hot and sends back long wave. White color sends back because it acts like a mirror. Okay, white color acts like a mirror and sends back. Dark color absorbs and it becomes hot and it sends long wave. So it's not like dark color sends long wave and white color sends short wave. That understanding will be wrong. Dark color absorbs, becomes hot and sends long wave. Short doesn't become hot, it sends back directly. So it will be short wave. Amrita, which part you want, ma'am? Water vapor will be having more radiation or reflection. Water vapor absorbs this, so it will radiate. Ma'am, whenever an object is hotter, let's say sun, then what comes is short wave. Whenever an object is cooler than sun, like earth is cooler than sun. So what it sends back is long wave. So if I have a mirror, short wave goes back. If I have a mirror, long wave goes back. This is called reflection. Mirror sends back. So that is called reflection. Okay. So guys, now let us talk about the next one. That is advection. Yeah, sun always releases short wave. Yes. Advection. And what is advection? Yes, one side I have high pressure, another side I have low pressure. Wind will move from high pressure to low pressure. Right? Wind will move from high pressure to low pressure. Then what is going to happen? This horizontal movement is called as advection. Horizontal movement of air is called as advection. And air, if it moves horizontally, we call it as wind. Air, if it moves horizontally, we call it as wind. Fine, guys? What is convection? Vertical movement is called as convection. Horizontal movement is called as advection. Horizontal to what? To the land. Horizontal to the land. For example, if I have a mountain like this, and if air goes like this, this is called horizontal movement to the mountain. This is horizontal movement to the mountain. This is also horizontal mountain to the movement. So this is also called as wind, because it is moving parallel to the mountain. So what is advection? Advection is horizontal movement of the air, guys. So ma'am, even if you have a mountain, right? If air is going from bottom to top or top to bottom, air is going parallel to the mountain. If it is parallel to the mountain, it will be called as wind only, advection only. Fine. Vertical is if it goes like this, if it goes like this, if it goes like this. If it goes vertically upward, then we call it as vertical. So can you people write advection, advection, hyphen, horizontal, horizontal, horizontal movement of air, horizontal movement of air is called advection. Horizontal movement of air is called advection. Full stop. Wind blows from high pressure to low pressure. Wind blows from high pressure to low pressure. Full stop. Horizontal movement of air. Horizontal movement of air is called advection. Sorry, is called wind. Horizontal movement of air is called wind. Yeah. Yes, before I go, I'll just tell you one thing. Till now, let me tell you, I did 2 classes of basics, and yesterday also I did the class. If you people have not attended those, if you have not watched those, right, then please watch them. Else your basics will not be clear. Right, and whatever I apply in future, you won't be able to understand. So watch them and attend live classes. Sometimes if you are busy, if you have not attended the previous classes, this is not like history or polity that if you come back and listen in between, you will understand. So my request is, the lectures are done in a systematic manner. So that's why it's very important for you that, like, see previous classes and then come, so that it will be helpful, because we have dealt with all these things. See, if you have more water or more air, I'll call it as high pressure. If you have less water, we call it low pressure. So if at all, like, I'm connecting these two, A and B. Water will not move from B to A. Water will move from A to B. That is, water will always move from where it is more to where it is less. That is called as moving from high pressure to low pressure. Yeah, so that ultimately both will be same. Ma'am, which one you want me to explain again? Ma'am, here you see, if I have high pressure on one side, if I have, like, low pressure, less particles on another side, water will move from where it is more to where it is less. That is called as advection. Okay, advection is wind. Yes, advection itself is wind. Correct. Vertical movement. See, whenever air rises like this and comes down like this, we call it as convection. If at all air moves like this, we call it as advection. Let me say I have a mountain. Here air is going like this, and here air is going like this. This will be called as convection. This will be called as advection. Okay. Okay. Now, the next topic. Heat budget. Guys, after heat budget, I will, like, take up questions. Whoever has issues that we can see. This refraction and all we'll see later. We have those topics separately. We will see them later. Here it is not so important. That's why I'm not talking about it. Yeah. At that time, make down all the points. Again, I'll explain because class doesn't move forward sometimes. So, heat budget. So now, this heat budget basically means how much of heat is coming, how much is utilized, how much is sent back. These aspects we try to study. Guys, now you see, first, Earth receives radiation from the sun. This is called as incoming short wave radiation. And when it comes, we have clouds. Clouds is there. Near the poles, ice is there. On Himalayas, ice is there. So because of all those, some part is reflected back. As you are aware, reflection here will be outgoing short wave. Now, when it goes back, geographers gave some values to it. Let us say whatever is coming is 100%. Whatever is coming is 100%. %35% is sent back, reflected back. As it is reflected back, we call it as albedo. So albedo is reflected part. So out of 100%, 35% is sent back. Now, remaining how much? 65%. Out of this 65%, in atmosphere, I have ozone. I have water vapor, which absorbs sun's radiation. Fine. Water vapor and, like, ozone absorbs sun's radiation. How much do they absorb? 14%. Incoming is 100%. Sent back is 35%. absorbed is 14%. Remaining is 51%. So that 51% is absorbed by the earth. Fine, guys? So now you see, I'll repeat. Whatever is coming is 100%. Whatever is sent back is 35%. Whatever is absorbed by the atmosphere is 14%. Now earth got 51%. That means from the sun, whatever we are getting, only half of it is absorbed by the earth. Now what earth will do? Earth will send back. Earth will send back radiation or heat. We call it as outgoing long wave radiation. And this radiation is absorbed by atmosphere. How much? 34% of this is absorbed by atmosphere. 51 minus 34 is 17. 17% is sent back in the form of long wave radiation. So out of 51, 34 atmosphere got, 17 was sent to space. Now together, atmosphere got 48%. Atmosphere got 48%. Now what atmosphere will do? After some time, atmosphere will send back long wave radiation. Atmosphere will send back long wave radiation. How much will it send? 48%. How much it got? 48%. All 48% will be sent back. So finally, what is going to happen? Whatever came will be sent back. Then you may ask, sir, if everything is sent back, why do we have temperature? See guys, if I receive today and if I send back today, earth will be cooler. If I receive today and send back after 2 days, the heat was there for 2 days. That is the reason we feel temperature. So how much came? 100% came. 48% came from the atmosphere. 17 was sent back from the earth. 35 was albedo. 48 plus 17 is 65. 65 plus 35 is 100. So what came is 100. What sent back is also 100. That means almost everything is sent back. This is called as heat budget. Yes, there will be plants absorbing, there will be here and there loss, but it is negligible. Whatever comes, we are sending back. This is called as heat budget. Now I will ask you a few statements, you see and tell. Sun is the major source of heat for earth. First point, sun is the major source of heat for earth. Second point, earth is the major source of heat for atmosphere. Earth is the major source of heat for atmosphere. Is that true, guys? Is that true? Which statements are true here? Both? Yes. Guys, what did we see? sun is giving main source of heat for the earth, and for atmosphere, earth is giving 34, sun is giving 14. So definitely earth is the major source of heat for atmosphere. Sanya, yes, due to climate change, that is greenhouse gases, heat budget is getting affected. How? Earlier, heat was sent back after 2 days. Now it is sent back after 2.5 days, or it may be sent back after 3 days. So climate change definitely affects heat budget. Yes, this is mains question, can be asked in the mains for 10 marks or 15 marks. How do they ask? What are the different means of heating of the atmosphere, or how heat transfer occurs in the atmosphere? You need to talk about conduction, convection, radiation, and then you need to talk about heat budget. Clear? Can you write heading heat budget of the earth? Heat budget of the earth. Yeah. Below that, can you draw this, guys? Please write below. Solar energy is the main source of energy, for different atmospheric processes. Full stop. The heat that is received may be reflected, absorbed, and radiated by earth and atmosphere. Next paragraph. This heat is transferred through conduction, convection, and radiation. Full stop. These processes are given different values by geographers. Below this, you write first point. Total incoming solar radiation. Total incoming solar radiation is equal to 100%. Total incoming solar radiation is equal to 100%. Second, albedo of the earth. Albedo of the earth is equal to 35%. Albedo of the earth is equal to 35%. Next, total solar radiation absorbed by atmosphere. Total solar radiation absorbed by atmosphere is equal to 14%. Is equal to 14%. Next, total solar radiation absorbed by earth is equal to 34%. Is equal to 34%. Sorry, 51%. Absorbed by earth is equal to 51%. Yeah, sorry. Below this, total terrestrial radiation absorbed by atmosphere. Total terrestrial radiation absorbed by atmosphere is equal to 34%. Is equal to 34%. Next point, total terrestrial radiation sent back to space is 17%. Sent back to space is 17%. Next point, total radiation radiated by atmosphere, total radiation radiated by atmosphere is equal to 48%. 48%. Thus, Earth and atmosphere through reflection, absorption, and radiation, sent back 100% of the solar insolation Thus Earth will have an heat budget. Thus Earth will have an heat budget which would be analyzed in a manner that incoming is almost equal to outgoing. Next paragraph. Due to climate change, or release of greenhouse gases, heat is trapped for longer duration. This is there in NCERT 11th standard as well, guys. They have given different values, but these values, if you remember, that should be good enough. And it is for mains, not for prelims. So just focus on that aspect. Now, guys, in atmosphere, for mains, ma'am, not now, mains. Yes. In atmosphere, you might have heard about troposphere, stratosphere, mesosphere, thermosphere. I'll come to that. But when we consider this troposphere, it is believed that if I take A and B, A is hotter and B is cooler. The reason, As I move above, temperature decreases. So guys, I am not telling you by some scientific thing, but I'm telling you from what we observe. So from what we observe, with increase in height, temperature decreases. Now I am going to give reasons for this. See, geography is not predicting or doing something. Geography is more about understanding what is the nature. So why in troposphere with increase in height, temperature decreases? So first basic thing is density, guys. Density. Guys, we already read this multiple times. That's why I told you basics are important to listen once. Like, closer to the earth, there will be more air particles. As I move above, there will be less air particles. More air particles means more temperature. Less air particles means less temperature. So I will have high temperature here, low temperature here. This first reason is density. Second reason is, can you people tell me 90% of water vapor is present in 3 kilometers. As I move above, water vapor reduces. Can you people tell me if water vapor is there, will it absorb sun's rays? Will water vapor absorb sun's rays? Yes. Will it absorb Earth's rays, guys? Yes. Can I say water vapor is absorbing both sun's rays and Earth's rays? If it absorbs, will it be hot? So second reason is water vapor. 90% of water vapor is in lower atmosphere, and as I move above, water vapor decreases, and if water vapor is there, temperature increases. So closer to the earth, water vapor is more, so temperature is more. As I move above, water vapor decreases. It is not associated with density, guys. Don't bring density. The simple concept is moisture. Okay. No, density is different. That density is different from this. Fine. This density is air is not allowed to go out because of gravity. So that is the density we are talking here. Third, okay. Yes, can you tell me what is the main source of heat for the atmosphere? What is the main source of heat for atmosphere? Is it earth or is it sun? Guys, for earth it is sun, but for atmosphere it is earth. Earth is the major source of heat for atmosphere. Just now we told, see, 34%. Just now we discussed. If you forget so soon, you see, density, that means when degassing took place, when Earth was releasing the air to the surrounding, what happened? Most of the air was held by Earth's gravity. So density is more. Second, 90% of water vapor is closer to the Earth. It absorbs both incoming and outgoing, so it will be hotter. Earth is the major source of heat for the atmosphere. So layers closer to the Earth will be hotter, and as we move above, it will be cooler. Because of these three reasons, in troposphere, with increase in height, temperature is decreasing. Can you people tell me now, with increase in height, if temperature decreases, what is going to happen is, will there be vertical movement or no vertical movement? Vertical movement exists. See, again, some people are telling no. So if you are telling that there is no, then yesterday what did we study? Convection. Vertical movement occurs. Fine. Yeah. Can you write below? Write below. Note. Note. First point. In troposphere, with increase in height, temperature decreases. In troposphere, with increase in height, temperature decreases. Because first point, density of air is more near the Earth's surface, because most of the air is held by Earth's gravity. Most of the air is held by Earth's gravity. Guys, I just want you to tell a basic thing. See, to explain why more air particles are closer to the Earth's surface, we almost explained for 15-20 minutes. Now, if you have not heard that lecture, if you are directly listening to this, doubt will come. I'm not telling it's your mistake. But what happens when I explain you also, even when you're asking me question, when I explain you also, I'll just tell in 1 or 2 lines. Then also the confusion will not be removed completely. So why do we take in detail classes? To ensure doubts are cleared. So without understanding the previous lectures, suddenly if you feel, okay, this is I will try to understand, effort will be wasted. Because when questions are being asked, I understand you're asking those questions because you are not understanding it, but that is explained for a longer duration before. So it's even if you ask me in the given time, I'll just tell for 1 minute or just 30 seconds. Okay, this is what is happening. Even then concept won't be clear. So please see again and again, right? If you don't understand, you ask, sir, I didn't understand this particular topic. Fine. But without seeing the previous one, if you ask same questions, what happens is your conceptual clarity will reduce. I won't be losing anything. I will be explaining. But the amount of effort that we took before will be different now. So don't lose out. You are given a golden opportunity where all the classes you can hear again, understand again. Fine. Once if it is clear, it will be clear. So without listening to lectures, thinking that I have read NCERT, I can understand basics. No, we need to know because questions come from this. Fine. Second, you write. Second, you write. 90% of atmospheric water vapor is present closer to the earth within 3 kilometers. Full stop. Water vapor absorbs incoming solar radiation and outgoing terrestrial radiation. So if water vapor is more, temperature increases. So if water vapor is more, temperature increases. Next point. Third, Earth is the major source. Of heat. Earth is the major source of heat for atmosphere. Earth is the major source of heat for atmosphere. And layers closer to Earth, will be hotter, and as we move above, it will be cooler. So guys, these are the three things about troposphere. We will see the remaining in the evening. Yeah, now those who have understood can leave, and those who have doubts, you ask me now. Whatever doubts you have, you ask. I'll try to explain. Cooler. Troposphere, don't say thank you because I will miss this. Atmospheric layer determines weather process how. Which points need to mention in this answer? Guys, we will be talking about atmospheric layers. Don't worry. Troposphere and all we will try to talk. Why sun's atmosphere is more temperature? Guys, sun's atmosphere will have fusion process. So if you have fusion process, more heat is generated, and the Earth doesn't have such process. So Sun is a star which generates the heat. Earth is not a star. Earth is just a planet which doesn't have its own source of energy. So Sun is hotter, Earth is cooler. Ozone layers absorb incoming. Okay. Ozone layer absorbs UV part, right? It absorbs UV part. It doesn't absorb, right? It doesn't absorb outgoing much. Any other question, guys? Yeah. Yes, it's okay. If you say thank you, we will lose it. I'll lose the questions. So please. Yeah. See, guys, the molecular composition of oxygen, if it is like this, the molecular composition of ozone may be like this. So what happens? Sun's rays, especially UV part, can be absorbed. So it's all about how they are arranged. So let's not get into the technicalities of that. Okay. Yeah. Guys, if you people feel like, sir, sometimes we are not able to understand, but we can't ask again and again, you can text me. I have given the number for that only. I'll explain again. So don't worry. Yes. If we use different colors, absorption and reflection changes. Correct. Yeah. See, uh, it is not about Earth is hot or cold. It is about Sun and Earth. So, Sun is very hot, so it radiates short wave. Earth is less hotter, so it radiates long wave. So yesterday I gave you this. If you have 100 degrees Celsius, and if you have 80 degrees Celsius, and you have 50 degrees Celsius, 100 degree will have short wave, 80 degree will have long wave, 50 degree will have longer wave. So compared to Sun, Earth is long wave. So don't think the other way around. Sun is short wave, Earth is long wave. Now let me take Earth and carbon dioxide. Carbon dioxide is getting radiation from the sun. And let me tell you that now this became hot, right? This became hot. Now carbon dioxide will send long wave. Why? If Earth is 30 degree, carbon dioxide absorbed heat and it became 20 degree. And carbon dioxide released how much? Long wave. Earth is releasing short wave. So compared to carbon dioxide, Earth is hot. So what Earth is releasing is short wave compared to carbon dioxide. Earth is releasing long wave compared to sun. Do you understand? Compared to sun, Earth is releasing long wave. Compared to carbon dioxide, Earth is releasing short wave. So everything is comparison. Okay, guys. Thank you all. We'll meet in the evenings. Thank you.
Thank you, sir.
Thank you, sir.